Hi everyone, this is Nithya Jayakumar, Professor in the Department of Information Technology at K.S.Rangasamy College of Technology. So the topic for discussion is Programmable Interrupt Controller, which is the IC number is 8259. This is an interfacing IC which can be used with any processors. So we'll have a discussion with this interrupt controller to be interfaced with 8086 microprocessor, which is a 16-bit microprocessor. This programmable interrupt controller is used for use with the 8086 microprocessor. It is capable of handling interrupt routines. So, what I mean by interrupt is any external devices that are the peripheral device. It can be either an input device or an output device, which requires the services of a microprocessor. They will interrupt the processor. So instead of handling all those interrupts by the microprocessor itself, we are handing over the task to the programmable interrupt controller, that is PIC. Here, the main function is the role of this interfacing controller is to handle the interrupts, so to make the task or to make the process easy for a microprocessor. So either it can be reading from a data from a keyboard from an input device or sounding an alarm for an output device. So to handle when you have multiple interrupts, we use this programmable interrupt controller, or you can also say it is a priority interrupt controller. So once an interrupt comes, automatically the service routine has to be executed. That is a program corresponding for the interrupt to be serviced has to be done based on the priority of the interrupts what we have assigned, and also if you have masked a particular interrupt, that also be taken into considerations. So we'll see how that has been working in this microprocessor. So coming to 8259, which is a programmable interrupt controller, it supports 8 input interrupts, and out of the 8 input interrupt, it will just issue only a single interrupt to 8086, that is a processor. You can also allow multiple interrupts, that is cascading of your interrupts is possible. That is each interrupt in turn will support 8 interrupts. So that's cascading of 8259 ICs can be done. So 8 into 8 in total we can multiply 64 interrupts to this processor. So what are the features is we can set the priority of the interrupts. So when you take a simple configuration where you have 8 interrupts, out of the 8 interrupts you can set priorities for the interrupts or mask a particular interrupt, and you can store the interrupt vector address. Interrupt vector address is the address in which your service routine for a particular interrupt. So service routine in the sense, if a particular interrupt occurs, you have a sequence of program to be executed for that particular interrupt that will be stored in a memory. So the starting address of that particular interrupt address routine is stored in a table which is called as an interrupt vector table, which holds only the address of all your interrupts. So that will be stored in an interrupt vector address. So here this is a block diagram of your 8259. So we have a data bus buffer from D0 to D7. That is 8-bit data can be transferred. It is a bidirectional. You can either read a data or write a data. Both are possible. It is a bidirectional. And you have a read-write logic. Whether you are doing an read operation or write operation, that will be activated. And this is for your chip select A0. And this is A0 is used for activating all your logic. CS is your chip select. So here, as I mentioned in the earlier slide, we have 8 interrupts, IR0 to IR7. This can be cascaded. That is, another 8259 IC can be connected to this interrupt 0, and another one more IC at interrupt 1. Likewise, 8 interrupts can be cascaded to 8 other 8259 ICs. So if you are doing a cascading, that can be done by means of these select lines. This is for your enabling process. And this is an internal bus is used for communicating between the program interrupt controller and your processor. And you have so whenever an interrupt comes, it will be given registered in interrupt request registers. Out of the 8 interrupts, whichever request has come, that will be noted in interrupt request registers. And then we have interrupt mask registers. Out of the 8 interrupts, if I don't want particular interrupt, that is IR not should not be allowed. If you don't want that particular interrupt, that can be masked. So whichever interrupt you don't want to allow, that can be masked using this interrupt mask register. And then Priority can also be set. If I want to give the interrupt 1 as the highest priority, that also can be set. So after doing all that process, you make use of a priority resolver. So if a particular interrupt has occurred, you give the interrupt request to the priority resolver. So it is a responsibility of a priority resolver to check whether the particular interrupt is masked or if it is having highest priority. If two interrupts are coming at the same time, let us say IR1 and IR2, we have already set IR1 as a highest priority. So if you both the interrupts are occurring at the same time, the priority resolver will give the priority only for IR1. So all this decision will be set, and then whatever the final decision you make, that will be denoted in an in-service register, and then it will be denoted as an interrupt to the processor. This is the way in which a signal will be interrupt will be given to the processor. If the processor is free to accept the request and free to service a particular interrupt, it will give a signal called as interrupt acknowledge. So this is the interrupt to the processor, and this is the interrupt acknowledgement from the processor. So this is a block diagram of 8259 programmable interrupt controller. So as I mentioned, interrupt request register, it is used to indicate all your interrupt levels which are requesting the service of a processor. In service register, it will store the interrupt levels which are the interrupts which are currently being serviced. So mask register is used for masking any particular interrupts. So totally 8 external interrupts are available. INT is for request to the processor, and INTA is acknowledgement for the processor. This is for cascading, and A0 is used for selecting the different control registers. So depend upon your masking or priority. That control can be done by using A0. So this is the sequence in which your interrupt has been serviced by means of 8259. Out of this 8 lines, IR0 to IR7, one or more of the lines may be go high. Correspondingly, interrupt request register bit is 1. So a priority resolver will evaluate the request based on the mask you are given and the priority you are given, and it will send the request to the CPU, that is your 8086 microprocessor. The processor in turn will send the interrupt acknowledgement. The highest priority interrupt will be serviced. So in service register will be set a highest priority on the interrupt which is currently being serviced. And then once a particular interrupt is being serviced, you cannot get accept a request from the same location. So that request register will be reset. Once it is being serviced, the request will be reset. So if I identified a particular interrupt to be serviced, identify the interrupt vector address corresponding for that interrupt. If IR1 is to be serviced, there is a table available where the address of the program corresponding for IR1 is there. So refer to that, identify the call address, that is go to that program location, service that location, and come back to the main program. So after servicing the interrupt service routine bit, once again, once you have set while you are servicing it, after you completed the servicing, it is reset, and then you have to come back to the main program. So this is a way in which a sequence of operations happen using microcontroller. Corresponding for this microprocessor, 8086 microprocessor, that is programmable interrupt controller. So where is this being applied? So 8259 has applications in different computer system, embedded system, industrial control, and telecommunication. In case of computer system, it is used for managing the interrupt from various devices such as either keyboard, mouse, printers, or any other peripherals. In case of embedded systems, if you get more interrupts from your sensors which are connected to your automated system, or your actuators, or any other input output devices, all will be managed. That is, whenever you want to manage the interrupts, the role of the processor will be shared by the programmable interrupt controller. Next, in also industrial control applications, when you get interrupts from sensor or controlling devices, that can also be done. In telecommunication services also, this is used for handling interrupts related to communication interface, error handling, and network protocols. So in this way, an interrupt controller will share the workload of a processor. So whenever an interrupt occurs, the processor has to check whether it has to be serviced or not, and then it has to process it. So all this load of the processor will be shared by the programmable interrupt controller, and it will make an efficient work to handle the interrupts. So this is the one Programmable Interrupt Controller which is 8259. It has plenty of applications in different sectors like computer system, embedded, industrial control, telecommunications. In our day-to-day life, we make use of the interrupt controller in handling the services of the microprocessor, or it can be either microcontroller also. Okay, thanks for watching. Happy learning. Enjoy the role of process in our day-to-day life.